Okay guys, so today we're going to be doing problems 14 through 16 on the ACT Math Form 1MC for years 2011 to 2012. Okay, so here we have a problem. The following chart shows the current enrollment in all the mathematics classes offered by Eastside High School. What is the average number of students enrolled per section in Algebra 1? Okay, so this is an interesting problem. We just are concerned with Algebra 1. So we're concerned with these three numbers right here. There are three sections, A, B, and C. There are three sections, A, B, and C. Okay, so in order to find the average number of students enrolled per section, we have to add the enrollment numbers, 24 plus 25 plus 29 in each section, so 24 plus 25 plus 29, and then we have to divide that by the number of sections, or we divide that by 3. And using a calculator, if you want one, if you don't want one, you can do that in your head. And when you divide that by 3, 78 divided by 3 is 26. So the answer we get is H, 26. Okay, so now let's do problem number 15. The school owns 2 classroom sets of 30 calculators each. So let's underline some information. 2 classroom sets of 30 calculators each, which students are required to have during their mathematics class. There are 2 calculators from one set and 6 calculators from the other set. 2 calculators from one set, 6 calculators from the other set that are not available for use by the students because these calculators are being repaired. For which of the following class periods, if any, are there not enough calculators available for each student to use a school-owned calculator without having to share? So this depends on the former table that we had, and we need to go back and copy and paste this. New, copy, paste. Okay, if we take a look at this, the table over here, let's get a magnifier. If we take a look at this, it says that the school owns 2 classroom sets of 30 calculators each. There are 2 calculators from which one set and the other set are not available for use because these calculators are being repaired. For which of the following class periods, if any, are there not enough calculators available for each student to use a school-owned calculator without having to share? So there are 2 classroom sets of 30 calculators each. That makes it 2 times 30 calculators. 2 times 30, which equals 60 total calculators. 60 calc. So out of those, 6 are not working from one set, and then 2 are not working from the other set. So that means 8 not working. Minus 8 equals 52 calculators. So in which of the following periods, remember periods, will there not be enough calculators? So we have several options. We have period 1, period 2, period 3, period 4, and there is no period 5, but we have period 6. Okay, so let's look at period 1. There's only one period 1, and that requires 21 calculators. Well, we have 52 calculators, so period 1 is out of the question. Period 2. Period 2. There are two period 2 classes. One of them requires 24 calculators, another requires 22. Well, if you add 24, 22 together, 24 plus 22, we get 46. Well, we have 52 calculators. Again, that's not 46, so period 2 is out. Out. Period 2 is out. Period 1 is out. Okay, now let's look at period 3. So there are two period 3 classes. One has 23 enrolled, and another has 25 enrolled. And this has to be less than or equal to 52 calculators. 23 plus 25 is 48. So these periods, number 3 is out as well. So since period 3 is out, we have period 4 only, or we have there are enough calculators for each class period. As you can see, period 4, we have two period 4 classes. One is 29 and another is 28. And when we add 29 plus 28, we get 57. As you can see, 57 is much greater than 52 calculators. Hence, the correct answer for the period where there are not enough calculators is period 4. The answer is C. Okay, so now on to our last problem for this video. Doo-doo, doo-doo, doo-doo. What expression must the center cell of the table below contain so that the sums of each row, each column, and each diagonal are equivalent? So the sum of this, and this equals the sum of this, and this, which equals this, and this. But we're given certain numbers here, or variables. This is in terms of variables. So 7x plus negative 4x plus 3x equals what? Well, 7 minus 4x is 3x plus 3x is 6x. Minus 3x plus 6x plus 3x equals 6x. So we have 6x. So x plus 3x plus this unknown value has to equal 6x. Well, x plus 3x plus y, or that unknown value, equals 6x. That's 4x. You subtract 4x from 6x. Y equals 2x. You get h. Okay, so that's our video for today, and I hope you enjoyed it. Have fun.